Yeah, thank you, Joachim, for this introduction. I'm Matthias Kovatsch. I'm with ETH Zurich. So I'm a research associate there, meaning that I recently finished my PhD there and yeah, continue a bit in the field of the Internet of Things and continue my research there. So the main thing why I'm here is to present the new lightweight M2M DevKit, as already said, which is a client simulator. So the main thing, it's mostly an educational tool for the developer to learn about the specification, how to use it, and to see it in action. And it can also be used to test and kind of improve your own implementation or get you started with your own implementation, and you already have some reference implementation to test with. So how does it work? So it's an interactive lightweight M2M client that runs from the web browser. So you can connect the web browser to a live lightweight M2M server. So that means that's an actual implementation of a lightweight M2M server where you connect your devices and you can attach to this server as well and then interactively control what this new client should provide and through that test all your features on the server implementation. That's the status now. So far we do the client and there's the plan to improve this and also have the server side later so that in the same way you can develop and test your client implementations. So the status currently, so we have this 0.5 version there. We have the client support. I just realized it's 8 OMA label objects. It starts with 0, so it's last number plus 1. Classic mistake. So we provide this, including the descriptions. So you will see later that you can browse the different objects, see the definitions with descriptions, what's going on there. And we provide the interfaces. So that's the registration interface, device management and service enablement, and the information reporting interface, which is this CoAP observe thing. And as I said, it's for educational reasons there as well. So we provide visualization of the lightweight M2M operations and how they map to the CoAP messages that are actually sent. And to get you started, the first time you run it, you get an interactive guide that tells you, okay, first do this, then go there. So how do you get started? With some experience I got from my CoAP project, I provide on the one hand a launcher button, so the first time you install it, a small button will appear that hints you, okay, I have to do that. You can click on that, you will get this small window where you can enter the URI of your lightweight M2M server, you hit OK, and then a new tab opens and you can start interacting. The other way, once you know how it works, is you can directly enter a URI into the address bar of the web browser. So for technical reasons, I had to use a different URI scheme, which is CoAP plus lightweight M2M. So don't get confused here. So the lightweight M2M doesn't use this URI scheme. It's not registered. The thing is, you have to tell something to the browser what to handle. So if you use CoAP there, I wanted to keep this for the more general copper client that you run raw CoAP messages and have a more degrees of freedom there. And if you say, okay, I limit this interaction to the lightweight M2M specification on top of CoAP, you say CoAP plus lightweight M2M, and then the web browser knows which kind of plugin to load to do this. So be aware of this. I put notes everywhere where this is mentioned in the documentation. So you do this, and the first thing you will see is this. So that's how the GUI looks like. We have this pane on the left. There is this one button that if it works, it goes green and says ready. And what you see at the bottom is the message log where you see all the CoAP messages coming in. So that kind of releases you from using Wireshark in parallel. You already see every CoAP message that ends up at this endpoint. And what you see here is the CoAP ping that we use to check if there is something, some CoAP server on the other side that responds. So if you receive the reset to that ping, it turns green. And oh, sorry, that's where it is. The next thing you do is you load your lightweight M2M client that you want to emulate in the web browser. Once you did this, you will see the tree of objects and instances that will be emulated by the DevKit, and you can browse them. So, and then in the main view, you will see, if you select an object on the left-hand side, you will see these definitions. So these are basically the tables from the specification where you see, what's the name, is it a single or multiple instance object, mandatory operations, and also this description. If you select an instance in this tree on the left, you will see the list of resources there, and you will also have this mask where you can then actually modify the data behind these resources. In the last row for this elbow, you also see that you can add resources. So some resources are optional; they don't have to be there. But you have this editing view where you then create your client. You say explicitly which resources should be there. And what you also can see, there's this notify button. So if some server or the server is observing this resource, you can manually trigger a notification there. So on the top, we see the 4 interfaces, the first one being the bootstrap. The bootstrap is currently always disabled because we use kind of the factory bootstrap here, because what you do is you enter the address of the server you want to contact directly in the address bar, and then you already have this information. The other thing is, we in the browser, this is educational, so we currently do not support DTLS here. You don't see much if it's encrypted, so that's why we always run the no-sec model, and you don't need the credentials there. So currently it's disabled. Maybe if there's need for that, we can extend this in the future. So the first active interface is the client registration. So once you loaded your client, the buttons will be enabled. If you click on it, you get this small pop-up. You can enter this registration data that will be sent in the query on the registration. You can click register, and then you get some information like this handle where you should send the updates. You see the last update time, and you also see when there will be the next automatic update. But you can also trigger this manually by clicking on update. And if you want to test deregistration, you can also click there. Okay, now you're registered. The next interface is the device management and service enablement. This is when the server issues requests to the lightweight M2M client to read out the data behind the resources or whole instances and so on. And what you see here, that we provide this log of operations. And if you select one entry in this log, you get the detailed CoAP message below there. So you see the base header, you see the options that are defined, and you can also look into the payload. So if it's text plain, you will just see the text plain to read it. And for the TLV, for instance, we provide this kind of hex view to see what is sent in this write operation in this case. If it's a read, you will see this payload on the lower part, where you have the response. Then the last interface is the information reporting interface. Here, if the server observes something like a resource instance, a resource directly, you will see these observe relationship on the top part. You also see the operation log, so when did the observe come in, when are there notifications, and you will also see cancel if the server canceled it. You can also manually cancel it by deleting basically the observe relation in the top part. And again, you can click and select them and see the CoAP message behind that, what you actually transfer over the CoAP protocol to implement these lightweight M2M operations. The last thing is the preferences menu. What you see here, there's a list of hotkeys that I'm continuously extending to give you a nice flow. Once you're familiar with the tool, it's pretty fast. You just hit E and then R, and then you're already connected. So you can run fast through the tests, and you add some other configuration if you want to test something specific, for instance, changes in the CoAP protocol. And lastly, this feature about this interactive guide. So the first time you run it, what you will see are these red bubbles, so these pop-ups, and they will guide you through the process. It's kind of like the numbers you saw in red. They will be there and tell you what you have to do. The first, once you finished, they will be disabled, but you can easily enable them again through the preference menu or using the hotkey H to enable them for this session. So it's already available. So we released the first version, which was the version before this test fest here started. It's on the add-ons page of Mozilla. So you can search for the OMA Lightweight M2M DevKit there. I'll also give you the link here directly. Currently it's this version 0.50. After this test fest, I will immediately release the version 5.1 that contains the bug fixes and additional features I developed during the test fest here. And as Joachim said, this is already on GitHub, so you can also directly use the source code. Maybe to make it clear, here on the add-ons page on Mozilla, we have the release versions, so those are more stable releases. And if you want to have kind of the bleeding edge of the development, you can clone the repository from GitHub and run directly from this source code. So you will always have the latest snapshot. And if you go on the GitHub page, on the lower part, you will find the README, and that gives you detailed instructions how to install the add-on from source code. If you worked with Copper before, you might already know this process. And yeah, the nice thing is you set this up once. You can directly run it in the browser. You do a git pull in the command line or whatever tool you use. So you do the update of the source code, and then you just hit F5 in the browser, and you have the new version of the DevKit running already. And yeah, it's source code. So it's based on Copper. The whole thing is implemented in JavaScript. So it's quite easy for you to extend it. And that's kind of also the idea. So if you want to change something, if you want to test something specific, you can dig in there and do so. So for that, I want to give a quick overview what you will find in the source code. So I was asked about this Chrome directory that is in there. Yeah, is there finally a Chrome port? Unfortunately, not yet. It's still something that is somewhere on my list I want to investigate. The way you develop extensions for Mozilla works that there's this Chrome, well, the Chrome you put on the bare metal, that's the stuff you see, that's the overlays and GUIs you see. So that's called Chrome in Mozilla. And that's basically the main folder where you find the main content. So that's the GUI and scripts that make this add-on work. And in content you find the active parts. So the first Copper being the CoAP implementation scripts to run this. And then there's the second folder, Lightweight M2M, which is the implementation of this specific implementation that runs on top of CoAP. Main.xul is the GUI layout that, like a web page, loads the scripts. So it's not directly HTML, so it's an XML-based user interface definition language. And it's sometimes a bit quicker than HTML, but it's yet another language you have to look into to know how exactly you create some specific elements. And the usual way there's a kind of main.js, which is the start script, so that's run on onload and then will trigger the first things like this CoAP ping and setting up some of the elements in the GUI. The other thing is the skin folder, so that's the CSS and images to how this add-on appears. So I don't plan to provide different skins because that's kind of not the point of this extension. The other folders, so there's a folder called clients. That's where the loadable lightweight M2M clients will be stored. So there are some JSON definitions, what objects are provided by the client, and what's the initial data they have in the resources. there's a components folder. That's, again, how you do add-ons, some specification there. The protocol handler script is put there so that Firefox knows, okay, if I enter this URI scheme, this add-on should be loaded. There's a defaults folder that's about, you set up some registry values. So if you enter about config in your browser, for instance, you get this internal data, so this kind of configuration registry, and there's something you set in the preferences, for instance, that's found there. Then the objects folder, that's where you store the lightweight M2M object definitions. It's not directly the XML, it's a JSON format, because it's easier to load it in this way. And I have some comments on this later on. In the last two files, there's a manifest that kind of maps, okay, where can I find the content, where can I find the skin, and so on. And the last one being the metadata for this add-on. So there you find the name, the version, and some identifiers. Let's have a quick look at the important part if you want to extend this, the lightweight M2M implementation. The first thing, CoAP handlers, that's kind of the message callback. So if you receive something, that's, for instance, where blockwise transfers would be handled, that only once it's reassembled and you have the full request, it will be forwarded to a specific resource. And other special handlings you can put there. There's a client handler that provides the client functions, so loading these JSON definitions and setting up the GUI with this tree and so on. Encoding, those are pretty clear, so we provide the JSON encoding and the TLV, so you have to implement that, that's done here. There's a helper thing, so if you have some small functions like converting an array into a hex string or something like that, that's usually put there. Then, quite obvious, we have split the implementation of the interfaces in different files, so if you want, I don't know, extend something in the device management, you go to this file. It should be pretty clear. This file is loaded by this loader, launcher.js. We have a logger that basically provides this visualization of the CoAP messages, and there are also some helper functions that allow you to debug JavaScript objects and to see what fields are there if you want to dig deeper and I don't know, provide some more details in the GUI, for instance. And the last thing, tooltips, that's this interactive guide that provides these pop-ups in the different stages. If you use it, we are hoping for feedback. So if you see something, have bug reports, comments, and so on, please send me an email. Or something that is also quite good, start using the GitHub issues section. So because then we have it documented there can be some discussion, and maybe different people come up with the same issue or the same idea, and then we can also see kind of which is the most wanted new feature that should go in there. So what's the outlook for the 1.0 release? So one is the custom lightweight M2M clients and objects, so that in your company, for instance, you want to prototype new devices, you want to decide which kind of objects you will need. That should be there, and also defining your own objects that are not registered yet, so you can play around with that. That should be integrated. For that, I want to talk to the author of the object editor to find a nice way to link this directly together. So there will be some tool to create your own objects and export them somehow, and to make it easy to feed this directly into this DevKit. What I noticed here at the test fest is that also Lishan, for instance, is using a JSON representation. I heard that for the ARM lightweight M2M server, there's some kind of configuration script where you also have the JSON format for these definitions. So it would be interesting to look into a common format that suits the different use cases we have. So for me, it's directly the data model. Because it's JavaScript, it's really where I store the data. And for others, it's for the GUI to configure how the GUI should look. So if we can combine these requirements, we could come up with a good reusable format for that. And what I found here, pretty convenient. Lishan, there's already a converter that converts DDF to JSON, so maybe that is already of help for you who also kind of uses this format. And the other big milestone for version 1.0 is the server support. So yeah, sometimes you're offline, you're in this protected developer environment, you don't have the online sandbox, and so that you can directly connect one tab of the client to a tab of the server. That's the idea here. And then, as I said, also testing your new clients. A technical problem we are still having here is that's in the browser, and at the moment you cannot open up a server UDP port that you will be available like a server running out there. A current fix for that could be that we use the server initiate bootstrap so that the server basically opens the connection to your client, configures it, and then it will be able to talk to you. We have to look into this, but this is the first thing we could make work, and then we have to see how we continue from there. That concludes the first part about the DevKit. So yeah, you can already try it. There's this 0.50 version. I already pushed updates to the GitHub, so maybe you can clone from there and use this current version, but it's already out there, you can have a look at it, and yeah, as soon as you got some ideas, please contact us for feedback. So yeah, because it's quite quick to explain this tool, we thought we'd talk a bit about CoAP implementations, because this is the basis basically for lightweight M2M, and what is available there. So a good resource already is this webpage CoAP.technology. That's something Carsten Bormann set up, and you have links to the specifications, and you have this section about implementations where it lists in different categories what open source but also commercial implementations are out there. So one of them is the Copper CoAP user agent. So that's the CoAP implementation the lightweight M2M DevKit is based on. So if you, for instance, want to provide CoAP support that goes a bit beyond lightweight M2M, so you have additional resources, want to explore maybe other standards that are based on CoAP where you have this nice combination, you can use this tool to use the raw CoAP protocol, have more degrees of freedom, what you do there, and look deeper into this protocol. So it's also available on the add-ons page of Mozilla. It adds the CoAP protocol handler, so you enter a URI with CoAP : something to open it. Just like the DevKit, you can browse the things. You can also just use the bookmarked feature of the web browser to store interesting lightweight M2M servers, or in this case CoAP servers. And the idea here is to have a tool like the REST client or Poster to debug and test your RESTful applications, but in this time running over CoAP. And if you want to include this somewhere, it's a free clause BSD license. Another project by me is the Erbium REST engine. So that's the default CoAP implementation in Contiki. So it's part of the Contiki operating system. And the focus here was actually to have a CoAP web server running on Contiki. It's similar to the concept you have in lightweight M2M. So the main thing is that you provide a server that hosts resources, so you can read out sensor values or write some parameters there, control actuators. And still there's some minimal client support so that you can do, for instance, the registration, which is similar to registration to the resource directory we have also defined in the IETF to have some kind of index what devices are there. It has a very small footprint, so if you enable every feature, it's less than 10 kilobytes. If you cut this down to only the features you need, you can end up with like 3 to 4 kilobytes. It's less than 1.5 kilobytes of RAM for the running system. And that might be interesting also for other systems. Contiki is made for these small, really constrained microcontroller type of devices. There also exist some POSIX ports, like Wakayama is actually based on this implementation, and there are also some others, even commercial ones, because we also use the free clause BSD license to reuse this code. Something similar there is the libcoap, so that's the library that was started in Bremen, where Carsten Bormann is a professor. So this is the more common or open approach. So it's a classic library where you have all these functions and then can build whatsoever from it. It's POSIX compatible, but there also exists support for TinyOS, for instance. So this is the other small operating system for wireless sensor networks. The thing is, there's a larger memory footprint because it's more generic. They are not these optimizations, for instance, that you find in Erbium, but that might be necessary if you have some special plans for your project. It uses a 2-clause BSD license and a GPL, so depending where you include it, so you have the freedom to choose the licensing model and to make both worlds happy, basically. Something that is interesting, because Node.js is pretty successful and a lot of developers are using it. There's an implementation for Node.js, so it's also in JavaScript, but optimized for Node.js, and it's modeled after the HTML module you also have for I think it should be HTTP module. Sorry for that. You can start a server and then provide your RESTful applications within Node.js running over the CoAP protocol, and it uses the MIT license. The last one is the Californium CoAP framework, which is hosted at the Eclipse Foundation. It's a Java framework, and this one is designed for the service backend. So that's, if your constraint device is a Raspberry Pi, then that's fair enough, but it's not made for these microcontroller class of devices. It's really for the service backend, and we put a lot of effort in scalability, so we have very high throughput. So on a normal i7, we evaluated it and then had almost 400,000 requests per second that it can handle. It comes with a DTLS 1.2 implementation called Scandium, and it's also the basis for Lishan that will be presented next by Julien. And it's also dual license, so the EPL, which is kind of like GNU, but we also have the EDL, which is kind of compatible to BSD, so you can also combine this with your own code and don't have to open source your proprietary code. So that brings me to the end. We have almost 3 minutes if there are directly some questions, but otherwise there's this session afterwards.